Hi, I'm Tom from Foxfield Instruments. We've made a set of 1U Eurorack tile modules for your modular synthesizer. They all come as DIY kits designed to be assembled by hand with common tools, and they all use surface mount components. This is our UtiLFO. It's a small 1U utility LFO tile. And here is all the componentry on the rear. It may look small, but it really isn't anything to be afraid of. So today I'm going to walk through building this tile with you and show you that you too can do SMD. This is what you get when you order one of our kits. Before you tear into it, note that URL on the front. That's for the build instructions and you're going to need it. Let's see what's inside our bag and open it carefully. We've got a tile tail connector, that's our power connector. We've got a few bags of small components that I'm just going to put to one side for now. We've got the mechanical bag, that contains things like jacks, LEDs, knobs and screws. And we've got the PCB and the panel. Oh, and we've got some merchandise, as always. The locations of individual components are described in the build document. It'll tell you what bags they come in. Don't tip them all out onto the table right now. Instead, take them out as you need them. They're very small and you might lose them otherwise. So we've got our kit in our workspace. What else do we need to assemble it? The tools I've got on my table for today's build are a soldering iron. I'm using an old temperature controlled Weller, but any good quality clean iron will do. Note that I'm not actually using a very fine tip. I'm using a small pencil tip. But by contrast, I am using fine solder, about 0.5mm. Fine solder will make your surface mount work a lot easier. I'm using lead and tin mixed solder. If you're using leaded solder, wash your hands after working with it, but lead-free will also work. I just prefer the leaded. A pair of angled metal tweezers. These are about £2 and they're critical for working with surface mount components. We've got something to remove solder with, just in case we make a mistake. Solder wick is very useful for SMD, and a good old sucker can come in handy. Some angled snips to cut the legs off components. I like right-angled ones like this. Wire strippers for our tile tail. Mine are particularly fancy. Something to hold the board steady with or rest it on. A cutting mat will do. I really prefer a PCB vise, but this was easier for filming on. Don't let the PCB slide around a bare table. And of course, a clean workspace. Seriously, give yourself space to work. Tidy up. You're working with a hot tool and you don't want to get tangled up or burn yourself. Now, this video will assume you already know the basics of how to solder, and there are loads of great DIY resources out there if you're not familiar. But beyond that, we'll try and explain as we go. We're going to start building the tile on the back of the board. So the back is the side without the jacks and pots on. This is where most of the components go. We're going to start by prepping the board for attaching parts to. That means we put a blob of solder on the rightmost pad of each 2-pad component. And then we put one on the top right pad of the IC, the chip. When we've done all that, we're ready to attach our first component. We'll start with the IC. We begin with this because it's probably the most fiddly component to attach, and it's in the middle of the board, and if we do it first, we'll have space to work around it later. Let's remove the IC from its packaging by peeling the tape off the top and getting it on our mat. You have to attach the IC the correct way around, and the way to tell which way that is on an SOIC chip like this is that one long edge of the IC is slanted, the other is completely right-angled. And if you're not sure which one you're looking at is the slanted one, trust me, the non-slanted one is very square and the slant is very pronounced. So that slanted edge corresponds to the thick white bar on our PCB outline. Here's the basis of how we attach a component. We pick it up with our tweezers and get it in about the right area. And then we take our soldering iron and heat that blob of solder we put down. And we just slide the component into place. We're trying to keep it flat against the board, not raised up or at an angle. And we want each of its legs to be perfectly over the marked pads. Then, when it's over the pads, we remove the heat to let it harden, and we remove the tweezers. If you're finding this hard, don't worry. You can take a break. You can remove the heat, give your hands a rest, and start again. But the trick is you heat up the solder, you slide the chip into place, make sure that all the legs are evenly over the pads, they're not at an angle, they're not on the wrong pads, and then remove the heat. And when the solder's hardened, you can remove your tweezers. When you're happy with the placement, we solder down the opposite leg to keep the chip in place and stop it sliding around. So take your iron, place it on the pad so it just touches the leg, and feed a splash of solder in. See, not too hard. Now we'll walk around the edge, adding solder to each leg. We need very little solder, so really go easy. Don't let it get too blobby and keep your iron clean. If you think it doesn't look like there's room to do this, remember your solder contains flux and that helps it to flow on metallic surfaces. More to the point, all this green on the circuit board is our solder mask. This rejects solder, so you'll find the solder will want to go onto the pads and the legs and nowhere else. Now you can see why that fine solder helps. If you do get a bridge between the legs, don't worry, we can remove it. Try swiping your iron deftly between the legs just to see if you can break it. And if that doesn't work, braid or a sucker will help you remove that excess solder. When you're done, let the board cool. It will be hot, and check that every pin has a good contact with the board. Once the IC is done, we're good to move on. Now we'll solder all the resistors and capacitors on the back, these little passive components. These are much easier than the IC. So we know which one goes where from the build document and the silk screen. The values of the components are written by them, sometimes with a line to indicate where they go. And the resistors are all marked with their values. The documentation will tell you which bag each resistor is in and exactly what the label on top of it will say. So for instance, let's start with the 4 1K resistors. These are marked 1000 on the top. We peel back the tape carefully and we tip them onto our cutting mat. Now we take one, heat up that solder pad we've put down and slide it in. Remove the heat and remove the tweezers. Once you've got it in place, you need to solder the other end. You could do that now, or you could wait till they're all in place and go around the board filling in the rear pads. I tend to fill in the second pad for each set of values at a time. Filling in a rear pad is easy. Take your iron and carefully place it against the unsoldered pad, just touching the edge of the component. Now feed the solder into the pad, and it should just flow between the pad and the back of the component, making a neat ramp. So let's speed this all up as I just go around adding resistors and capacitors to the panel. Note that all these components can go either way round, they're not polarized. They can also go any way up, but let's keep the values on the top because that makes debugging easier. If you're wondering how those resistor values work, well, the final digit is the power of 10. So for instance, 1003 really means 100 times 10 to the 3, which is 100 times 1000, which is 100k. The capacitors aren't marked, so be sure to read the build guide for which is in which bag and which goes where. And there we are, all done. Now we'll flip the board and prep it like before, one blob on each of the sides of the component pairs. Let's start with the front passives. So first the fuses. These are just like the resistors, they can go any way around, they're quite straightforward. Now we've got a pair of diodes and a pair of aluminium capacitors, and both these components are polarized. Diodes can only go one way around. You know which way they go because there is a faint line on one end of the little diode. That corresponds to the narrow end of the triangle on the PCB. If it helps, think of it as completing the triangle in a diode symbol. If you can't see the line, a torch on a cell phone camera will help you a lot. So we put a blob down, we slide it in, and we're done. And then we can do the other end as before. The aluminium capacitors are also polarized, but it's way easier to say how. Their base is asymmetric and they've got this black shaded line. So line them up with the outline on the board. The angled ends and the shaded part of the can should correspond to the marking. It might look a bit hard to solder the other end of the capacitor, but the solder really will flow. So just go gently and you'll be fine. And now we're onto the home straight. You might be a lot more comfortable with this part. We'll do the through-hole components from the mechanical bag. We put the jack socket, the pot and the LED in place. Remember, the flat edge of the LED lines up with the flat edge on the diagram, which is also where the short leg is. When they're all there, we don't solder them in place. Instead, we attach the panel and we screw the pots and jacks down. Now we can flip the board and solder our through-hole components. Nice and easy. A PCB vise makes this even easier. With the LED, we want to get it to the correct height in the front. One way of doing this is putting a little electrical tape over the hole to stop it falling through. Another is to solder one leg and then carefully position it whilst keeping the solder on that leg hot. And when you've got it to a height you want, remove the heat, let it cool, and solder the other leg. And now we snip those legs when we're done. Finally, we're going to attach our power connector. We take the tile towel and we separate the wires, strip them and tin them. Tinning is important, don't skip it. You can see I snip the ends once they're tinned to keep them nice and thin. Then we take the board and we insert the tail from the rear. The rear shows us which wire goes where. Black goes to ground, red to positive, and white to negative. Once that's in place, we solder it from the front and snip the ends. All that's left is to assemble our tile, put the panel on and screw everything into place. Turn the pot all the way to the left. Take the knob and align it with the markings on the panel and then use the set screw to fasten it. And that's it, we've made our LFO. Let's test the tile. We could plug it straight into our full Eurorack, but I recommend plugging it in isolation. It's always best to be safety conscious. Maybe you have a spare rack, or you have a bench power supply, or a module tester, or a spare PSU. Here I'm using Citizen's USB power board. I've attached a Foxfield tile tail adapter and a USB battery, and that's going to be enough to power our single tile. And there we go. We turn it on and we get the triangle wave out, which you can see on the LED. And I can plug in a test jack to prove that the square out, derived from the triangle, is also working. And that's it. All that remains is to screw it into your synthesizer and get playing. You could use it as a little performance LFO to add some modulation, or a modulation source that's just fixed and running, or you could use the square out as a clock and the triangle out as an LFO that's synced to the tempo. It's up to you. More to the point, now you know that SMD isn't scary. You can do this. And if you think you can do this, then you can do all our tiles. We don't use any smaller components, and it's really just a case of following these techniques, going carefully, and you'll be fine. Hope that was instructive, and see you soon.